Recently, something big happened, a truly huge leap forward, and I'm super excited about that. And it's wild, because just a little while ago, we thought we had AI figured out. It was basically a clever parrot, right? It could mimic human language, write a silly poem, maybe even help with some code. Okay, they were really capable of these kind of stuff. We saw it as a tool, a novelty, and we were using in our daily lives. This was the same tech that we would hilariously fail to count the letter R's in strawberry. Simple strawberry word, right? We thought we knew its limits, but the pace of change has become a blur. And in that blur, a line was just crossed. Not a small step, but a giant paradigm-shattering leap that forces us to throw out all our old assumptions about what a machine can do. Hello everyone, I'm Uğur and welcome to Mind Matter. Today we are breaking down that pivotal moment. Google's Gemini AI won a gold medal at this year's International Mathematical Olympiads. So how did an AI operate at this elite level of human reasoning? What new approach made this possible? And most importantly, what does this mean for us? Let's get into it. First thing first, let's establish the context. The International Mathematical Olympiads, or IMO in short, is the world's most prestigious mathematics competition for the pre-university students. It began in 1959 and has since grown to include over 100 countries, each sending their top 6 students. The competition itself is a formidable intellectual challenge. Over 2 days, contestants have a total of 9 hours to solve just 6 problems. These aren't standard textbook questions that we used to it from our math classes. They are deep inquiries into algebra, geometry, and number theory that demand not just knowledge, but significant creativity and insight. Calculators are forbidden, of course. It's pure test of logical reasoning. Medals are awarded based on performance, but gold medal is reserved for the absolute top tier, typically on the top 11% of contestants. The IMO is a benchmark for the highest level of mathematical problem solving among the next generation of human thinkers. AI has been tackling math problems for years, but previous attempts had limitations. In 2024, last year, Google DeepMind's combined AlphaProof and AlphaGeometry systems achieved the silver medal standard, solving 4 out of the 6 problems and scoring 28 points. However, last year, AlphaGeometry and AlphaProof required experts to first translate problems from natural language into domain-specific languages such as Lean, and vice versa for the proofs. It also took 2 to 3 days of computation to calculate all of the results. This year, that drastically changed. Google's Gemini model computed under the same conditions as the human participants. It read the problems in plain English and produced the complete rigorous proofs within the official 4.5-hour time limit for each session. The result? Gemini solved 5 of the 6 problems perfectly, earning a score of 35 out of the 42. This score met the exact threshold for a gold medal. And here's where the story gets spicy. The IMO's own coordinators officially graded and certified the results, calling the AI solution clear, precise, and most of them easy to follow. This was a little bit different from some other claims like OpenAI, floating around, which were graded, let's say, internally by former medalists and announced with a speed that ruffled a few feathers in math community. Google, on the other hand, waited patiently, respecting the IMO's request not to overshadow the student winners. So, what enabled this leap in performance? The key is a new reasoning architecture Google calls DeepThink, which is powered by a method called parallel thinking. To understand why this is a big deal, let's first look at how AI has traditionally reasoned until today. Most AI models have drastically used linear or sequential reasoning. They start at point A and follow a single chain of logic to get to point B and then C and so on. It's like walking down a path, and if that path is a dead end, the AI has to backtrack and start over. It's methodical, but it can be slow and inefficient, especially for complex problems with many possible routes like IMO. Parallel thinking is completely different. Instead of a single path, the AI explores multiple lines of reasoning or potential solution paths simultaneously. It's like a search party spreading out. The model develops and evaluates many different hypotheses and strategies at the same time. It can see which approaches are promising and which are failing, and all in real time. It can even take a useful insight from one path and merge it to another. This ability to explore, cross-reference, and synthesize multiple lines of thought at once is far more robust and efficient. It's a closer approximation of how human experts often work through difficult problems, and it was the key to Gemini's success under the IMO's demanding time constraints. But Gemini's performance also revealed the current frontier of AI reasoning. It solved 5 problems perfectly, but it scored 0 on the 6th. Problem 6 was an exceptionally difficult combinatorics problem that stumped almost all the student competitors as well. But why? Problem 6 required a foundational, non-obvious creative insights, a big idea that wasn't accessible through standard techniques. Current AI, even with parallel thinking, excels at exploring a defined space of possibilities. It's less capable of inventing a completely new conceptual framework that redefines that space altogether. So, what is the real takeaway from this? It's not an AI is smarter than humans. The IMO is competition for very bright young people. Frankly, when I first read the problems, I couldn't even comprehend what they were asking. The vast majority of the adult population couldn't solve these problems either. The true significance is that AI is beginning to excel at a level of creative reasoning that was previously exclusive to a small fraction of human minds. As some have pointed out, it's genuinely impressive, but we also need to see the receipts, the methodology behind the magic of Google. This marks the beginning of a new era for how we work and think. We are seeing the emergence of a new kind of a tool, a new kind of intellectual companion. Instead of fearing this, we should be focused on how to use it. And this feature is closer than you might think. Google has already announced that this DeepThink technology is being prepared for public release. But there is a reality check. Initially, access will likely be limited to premium, expensive subscription tiers. But the fundamental challenge for us is not to compete with these systems, but to learn how to collaborate with them. We must learn how to ask the right questions, how to guide their reasoning, and how to integrate with their power into our own workflows. This is how we advance. By embracing tools that augment our own abilities, we can push the boundaries of what's possible together. What are your thoughts on this? How do you see AI changing the way we approach science and learning, math, all of the things? Share your ideas in the comments below. If you found this useful, hit the like button and subscribe to MindMatter for more explorations into our changing world. Thanks for watching. See you next video.